Welcome to Learning Intention 2.9 Kinematics. Kinematics is the study of the motion of objects. For simplicity and to establish a link to calculus, only motion in a straight line will be considered at this stage. Imagine a particle is moving backwards and forwards along a straight line relative to a given reference point, usually labeled 0 and referred to as the origin. At any time t, we can measure the displacement from the origin, where displacement is just a fancy name for position in this case. Alright, since this is changing all the time, we allow it to be described by a function of time. And we call this function s of t. Or, alternatively, x of t, or h of t. From our study of junior science and or physics, we know that average speed is equal to the distance traveled divided by the time taken. Conversely, average velocity is equal to change in position divided by the time taken. And this can be written as s of t1 take s of t2 all divided by t2 take t1. Now, bringing sense to all that, what I'm going to do is I'm going to quickly draw a little diagram. Alright, so earlier I mentioned two different things. So we were talking about the difference between distance traveled and displacement. So consider this little diagram here, clearly not to scale. Imagine that we've got, we've got a tennis ball here, and your mate's standing at position -1, and they throw it backwards. And it goes all the way backwards until it hits a wall at -6, hits a wall and it bounces backwards. Then it does a complete U-turn and keeps going forwards until one of your friends at position 7 catches the ball and then launches it backwards to one of your other mates at position 3. So what we find is that if we were calculating the distance traveled of this ball, we'd have to trace all the way along like so. Alright, to calculate the distance traveled, then all we need to do is sum up the length of these straight lines like here, here, and here. Now summing them up, the first line goes from -1 to -6, so it's a distance of 5 plus -6 to 7. That's going to be a distance of 13. And then finally, the distance of 7 to 3, that's a distance of 4. So the total distance traveled is going to be 5 plus 18, and plus 4 is 22. So the distance traveled is a total of 22 units. But now what about displacement? If remember we start here and we finish here, then the displacement itself is simply the distance between here and here, so this length here. Now looking at that, we know that it's going to be a length of simply 4 units because we started at -1 and we moved forward to 3. So what we can see is that the difference between distance traveled and displacement is that distance traveled is the length of the entire trip, whereas displacement is simply the distance from your starting and finishing point. Alright, moving down. Consider the change that occurs between times t and t plus h, a short time after t. average velocity equals s of t plus h minus s of t all over t plus h minus t. And all of that simplifies down to s of t plus h minus s of t all divided by h. So see the similarity between this and first principles. Graphically, the average velocity is the slope of the chord on a graph of displacement versus time, which can be calculated using the formula above. If we allow for the time interval to become smaller and smaller, then we approach the quantity known as instantaneous velocity, i.e., velocity at any moment in time, v of t. Moving down. As the time interval becomes smaller and smaller, such that h approaches 0, instantaneous velocity can be defined as the limit as h approaches 0 of s of t plus h minus s of t all over h. Thus, the function defining velocity v of t is said to be simply s dash of t, or the first derivative of the function describing displacement. Graphically, the instantaneous velocity is the slope of the tangent. Likewise, working with v of t, we could demonstrate that average acceleration is equal to v of t2 minus v of t1, all divided by t2 minus t1. And going forward, instantaneous acceleration can be defined as the limit of, as h approaches 0, of v of t plus h minus v of t, all divided by h, and the function acceleration, or a of t, is equal to v dash of t is equal to s double dash of t. So what we can see is what we've got here is a second derivative. Moving down. Each time the displacement function is differentiated with respect to time, a rate per unit time is calculated. So for example, if displacement is measured in meters and time in seconds, the units of velocity are meters per second. And the units for acceleration are meters per second squared. So we'll leave it here for now, and then in the next video we'll do a few examples.